Hey everyone, the last thing we need to be able to do for this chapter is to determine whether a relationship or an equation represents a function or not. So some things that we can look at represent functions and others don't, so we need to be able to tell the difference between the two. So a basic definition here, and then we'll go through it in more detail, but a basic definition of a function is an equation where every input has exactly one output. So for an example, we've been talking about functions that look like this. So maybe we have a function f of x equals negative, 2x plus 3. So let's say I have this function and I'm going to put in an input, and let's say my input's negative 1. So I'll do f of negative 1. We know to find the value of negative 1, or to find that output for f of negative 1, we're going to use our equation here, and we're going to substitute negative 1 for our input. Now, if I evaluate that, I have a negative 2 times a negative 1 is a positive 2, plus 3 is equal to 5. Now, since plugging in my input of negative 1 gives me only one answer, this is a function. So I'm going to make a note here. Is a function. Because when I plug in my input, I only get one output. That's what's going to make us a function here. So for characteristics, I'm just going to say this in a slightly different way. Kind of when I think of functions, I think that each x, or input, can only be matched with one x, or excuse me, one y, or one output. So each x can only be matched with one y. For each input, there's only one output. So I'm actually not going to worry about the non-example here. When we start looking at function tests in just a minute, we'll look at examples and non-examples. And we're going to look at different representations. So here we looked at an equation, but we're also going to be looking at tables and graphs and ordered pairs. So let's see what that would look like. All right, so the first thing we're going to look at here, again, we're testing whether or not it's a function, and we're going to look at if it's a table. Now, we said that each x, each input, can only be matched with one y if we're a function. When I look at this first table, I notice that here I have x paired with 1. I have 2, my x value 2 is paired with 1. And here I have that same x value 2, which is paired with 4. So really here my input is matched with two outputs. That can't happen, right? So my input, which is 2, is matched, see if you can read that, is matched to two outputs. Right? It's matched with 1, it's matched with 4. Since we know that can't happen, we would say this is not a function. So my first table is not a function because I have that input matched to two different outputs. Now, in my second example here, I actually don't have any inputs that repeat. So 2 is matched with 1, 3 is matched with 2, and 4 is matched with 3. Since each input only has one unique output, this is a function. Okay, so one way we can check if it's a function is if we have a table. The second way we're going to check is from a graph. And again, the idea here is still the same, right? Our big idea is each input can only be matched with one output. So let's see what happens here. Let's look at our first graph. Let's take the x value of 1. When x is 1, I know that I have this point here, the ordered pair 1, 1, but I also have this point here that has an x value of 1. So if I look at those points, the points are 1, positive 1. This is 1, negative 1. That clearly violates our rule. Here I have the same input matched to two different outputs. So this one is not a function. Now, when we're looking at graphs, we actually have a test, an easy test to tell whether something is a function, and that's called the vertical line test. And here's how the vertical line test works. If I have my graph, anywhere on that graph I can draw a vertical line. If that vertical line intersects my curve in more than one place, so for example, here it intersects here and here, if it intersects in more than one place, then we do not have a function. So let's see what happens here. If I draw my vertical line, let's say here, I only intersect it in one place. If I were to put a vertical line here, I again only intersect it in one place. There's no place where if I drew a vertical line, I would intersect it at more than one point, so we would say this is a function. So the vertical line test we're going to use when we're determining if it's a function or not from a graph. All right. Now, another representation we might have is a list of ordered pairs. And this is going to be very much like the idea of looking at a table. I'm just looking to see, is there any x value that's matched with more than one y value? So if I look here, I notice in this case that 2 is matched with 1, but 2 also has an output of 5. Since the input 2 has two different outputs, we would say this is not a function. In my next example, let's see, my input is 2, it's matched with 1, 3 is matched with 2, 4 is matched with 3, and 5 is matched with 4. I don't have any single input that's matched with two different outputs, so this one's okay. This is a function. All right, and the last representation you might see here is what we call a mapping diagram, and it's really similar to a table, except it's going to use arrows. So again, I keep saying this, but our big idea here is that for a function, each input can only be matched with one output. So I'm going to notice right away in a table, or a mapping diagram, that I have a problem if I see one input that has arrows going to two separate outputs. This tells me that the input of 5 actually has two outputs, so I know this is not a function. Now here I can see each input is only mapped to one unique output, so this is a function. So the next activity that you're going to do, you're going to go into Desmos and you're going to do a sort. You're going to sort things that are functions and are not functions, and you'll be looking at these different representations. So I hope that was clear from the video. If you have any questions, please be sure to ask. Reach out to me via email, and I will see you when I'm back in class.